Now, when you apply the discriminant analysis methodology in SAS, SAS generates what are called Fisher's linear classification function. So it'll give you a regression analysis like equation, right? So you calculate using those equations. You'll have one equation for each target value. So if you have target value class equal to 0, class equal to 1, you'll get one function for 0, one function for 1. And if you have more than one, okay, if it's a nominal target and you have 5 different possible values, you'll have 5 discriminant function. And then you'll use the discriminant function to find the discriminant score for each class. So here in this example, again we're going back to the owner and non-owner riding lawnmower case. So when you run this in SAS, so this is the discriminant function that you get for non-owner, and this is the discriminant function you get for owner. Then you have a record, you plug in the values into this function, and you get the discriminant score. Now here the discriminant score is similar in concept to the distance, but it's not the same. So this actually measures how likely the record is to belong to the class. So larger values means more closer to the particular group. So since the non-owner discriminant score is larger, then you use non-owner as your predicted class. Now we can use these discriminant scores to convert it into propensity, the probability of belonging. So this obviously is not probability, because this is not a value between 0 and 1. So to compute probability, we have to use a formula. Okay, so this is the formula that we use to convert the discriminant score into probability. So if you have m classes, so you'll have the discriminant function value for m cases, right? Then you take each discriminant value, you apply it in this formula. So e to the power of the first discriminant value, e to the power of second one, and so on through the m classes, and add them up, and that goes in the denominator, and then you put individual discriminant scores in the numerator, and that will give you the probability of that particular class. So here is for our example, this is the discriminant function for non-owners, and we already computed the discriminant score 55.17. For owner it is 53.19. So find e to the power of 55.17, e to the power of 53.9, add them up, that goes in the denominator, and you take the discriminant score for the non-owners, put it in the numerator, and you find the propensity for non-owners. Okay, and then put the e to the power of discriminant score of owner in the numerator, and you get the propensity for owner. So again, using the propensity, of course, you're going to get the same result as far as classification is concerned. So for the purpose of classification, you don't need to compute the propensity. You can do that based on the score. But if you want to develop lift charts and ROC charts and so on, you need the propensity. Then you need to compute the propensity and set up a threshold value and do the rest of the computations based on that.